All right, so today is day 3 of solving linear equations. So the goal of today's lesson is that you can solve multi-step linear equations with variables on both sides, including the use of the distributive property. So a reminder of the distributive property, you would have A, B, and C. You would have two values inside a parenthesis, most likely with some adding or subtracting in between them. And then we would distribute this term from the outside, and you would have each term on the inside multiplied by the term on the outside. The part of combining like terms, this is when we have two values that have similar terms. We'll go with 3 here, plus 4y. I can combine the 2x and the 3x, but I can't combine the 4y with those. So 2x's are here, 3x's are here, so there's 5x's total, plus 4y, because the 4y cannot combine with the x's. Step 3 is moving variables terms to one side. So this is going to be when there's an equation, and we have something like 2x plus 1 equals 3x. We're going to take our smaller term, and we're going to move it to the other side. And when we move it, if it's positive, it becomes negative, and if it was negative, it becomes positive. So we subtract it away, and here we're left with 1 equals x. 3x minus 2x is 1x. Add and subtract to isolate the variable. Again, this is the zero pair term. And then multiply or divide the variable. Remember, this is going to be when we have something like 2x equals 4, we do the inverse operation. And this becomes x equals 2. So what you'll notice is I'm going to try and keep each one of these steps with these colors. But we always start with distribute, combining, moving, add and subtract, multiply, and divide. Or the acronym that you'll see on some of our posters, don't call me after midnight. So here's the difference between problem number 1 and problem number 2. So we want you to look at this problem and notice what the difference is compared to here. If you look here, the variable term is on one side. So this is referring to this step right here, this third step. Here, both of the variables are on the same side, so we can combine them. So we can actually treat them like this second step right here. 4x, negative 4x plus 8x. So if I have 8x's and I take 4 of them away, I'm left with 4x's. This is combining like terms. When it's on one side of the equation, we are combining like terms. And we always want to do this before we start moving stuff on either side. Here, on problem number 2, we have the variable on both sides. So this is referring to this third step where we have to move the variable term from one side to another. And when we do this, we always want to move the smaller value. And the reason we do this is that we keep our variable term positive. So I have 5x's over here. I have 3x's over here. I want to move this 3x because, again, this 3x is smaller than this 5x, and I'm going to take this 3x's away. So when I move it over, because I go across this equal sign, it changes it from a positive to a negative. It doesn't change it over here because I didn't cross the equal sign. So they stay with their values. Here, and I can just combine them. Here, because I move it over, it changes its value. 5x minus 3x is 2x. So we move by adding or subtracting. Okay, so let's see this in action. Here we have problem number 3. Problem number 3 reads 8m minus 5m minus 7 equals negative 3. So the first thing I'm going to do, you don't have to do this part. I'm going to put don't call me after midnight. So I can just mark off each step. First, do I have any parentheses? No. So I don't need to distribute. Done. Step number 2, combine like terms. If I have two terms on the same side of the equal sign, I combine them. So if I draw my line here, these two terms are right here, so I combine these two. 8m's minus 5m's is 3m's. Nothing happens with this negative 7. Nothing happens with this 3. That step is done. Step 3, move the variable term to one side. So I look to see if I have variables on both sides. This side has my variable of m. This side does not. I don't do that step. It's done. These final two steps I'll almost always have to do. Add or subtract to isolate the variable term. Now I'm trying to get the variable all by itself. All the steps prior to this was trying to unlock and crack this equation just so that way I could get the one single variable. Now I try and isolate it. Okay? I have subtracting 7 here, so I'm going to do the opposite. The zero pair of negative 7 is positive 7. This becomes 3m. Negative 7 plus 7 goes away. 3 plus 7 is 10. I have added or subtracted. My final step, multiply or divide to solve for the variable. Here I have 3m. I need to do the opposite of multiplying by 3, which is dividing by 3. I have m equals 10 over 3. This is an improper fraction. This also is a fraction that would, if we go through it, would end up with a decimal. And it's going to be a repeating decimal. It's going to go on forever. Don't worry about it. Leave it like this. What I care about is this stuff up here. I don't care that you can break down a fraction. I care about all of these actions up here. Okay, same thing on this side. So I'll go ahead and write it right over here. Don't call me after midnight. Step number 1, distribute. Do I have parentheses? I sure do. I need to distribute. I need to get rid of the parentheses first. They cause the biggest problems. So 3 times d is 3d. 3 times negative 2, negative 6. This stays as negative 6. This stays as positive 4d. My distributing is done. Step 2, combine like terms. I have a d on this side. I have a d on this side, but I don't have any terms. I don't have multiple variables on the same side. Here I had the m's together. Here the d's are separated, so there is no combining of like terms. Even this negative 6 and that negative 6, there's nothing to combine it with. There's not additional adding or subtracting with constants. So there is no combining like terms. I'm done with that step. Step 3, move the variable to one side. So here, now I'm going to be moving one of these. I have 3 d's over here. I have 4 over here. This 3 is smaller than the 4, so I'm going to move it over here. It was positive. Now that I cross this equal sign, now instead of it being positive, it's now negative. Nothing happens to this negative 6. It comes down. Nothing happens to this negative 6. It comes down. 4d's minus 3d's is 1. So you can either write plus d or just 1d. I always want to move the smaller variable because that will keep this positive and it'll make things easier later on. All right, that step is done. Last 2 steps. Now it's add or subtract. Now it's a 2-step problem. This goes back to like 7th grade. This is how I solve this. Add or subtract both sides. I need to isolate this guy. The opposite of -6 is +6. My 0 pair. So I'm going to add 6 to both sides. This goes away, which is what I wanted. I'm left with D. And this is 0. And because there's only one D there, there's no sense of multiplying or dividing by 1. This step is done. So that just says D equals 0. That means my solution is 0. So if I plug this in, if I plug 0 in, this is 3, 0 minus 2 equals -6 plus 4 times 0. 0 minus 2 is -2. 3 times -2 is -6. 4 times 0 is 0. So -6 plus 0 is -6. So that works out. I can plug these in and double check ourselves. So out of all of the numbers in the real world, all of the real numbers, positive, negatives, infinity, all of them, 0 is my solution for this question right here, which is crazy, but it works out. What I'd like you to do is work with a partner to solve each of these, and then I want you to compare each other's answers. Your solution, should be -20. So work it out to make sure that you get that as an answer.